Today we're going on an adventure to find some gold-bearing quartz veins. We're going to use a little bit of knowledge, a whole lot of luck. We're going to see some awesome views. We're going to break some rocks. We're going to talk about geology. We're going to go climb up through some nasty brush looking for gold. So let me put this video in a little bit of context. The Mount Baker mining district was prospected really heavy back about 1897, 1898. For about 2 or 3 years, thousands of people came out scouring these hills looking for gold. There were some really rich deposits found, but I think there's still more to be found. So today I wanted to show you how we can use some of the same tools they did with a little bit of new knowledge and a lot of luck, and see if we can find some new undiscovered gold veins. So our first step is going to be to get down to the creek here in this valley. We're going to go down into Ruth Creek. I'm going to pan for some gold, see if I can find any free liberated gold chunks, and that'll tell us if there's gold up in this valley and how far up we need to go to look for it. So there were probably 3 major producing mines that occurred in the Mount Baker mining district, and they produced gold and silver up through the 40s until the last one closed kind of right during World War II. In the Ruth Creek drainage, there were no producing gold mines, but hopefully once we get down to this creek, I can show you it has gold in it, and it's fairly coarse, so it hasn't traveled a long way down the creek from the source. And using our new geologic maps, there is a contact in this drainage that is the same contact where 2 of the other major producing mines were founded on. And so today I want to go up and explore that contact a little bit, because just over the hill there are 2 mines that produced thousands and thousands of ounces of gold. And so my theory is that if the contact is the same and the geology is the same, that's where I want to go look for new gold veins. Now I'm walking along this gravel bar. I'm seeing 2 distinct rock types I want to show you. We have this rock, which is called Darrington filite. It's a metamorphosed sedimentary rock. And then we have rocks like this, which are an intrusive volcanic rock called, Granite. There's a whole bunch of different names depending on the minerals in there, but we're going to call it Granite today. And later on in the video, we're going to go up to the spot where the filite and the granite are touching. Hey, that's a big rock. I think the monster came off the mountain and is sitting right there in the creek. That thing must be 40 feet high. Okay, don't tell my wife or my mom. We got to cross 20 feet above this creek here. And I hope this log doesn't break. But I want to get back over there where there's some exposed bedrock if I can find it. The water's really up right now because the snow's melting off. It's mid-May, so it might be a little bit harder to find a good spot to pan, but I just want to prove that we can find some really coarse looking gold in this creek, and then we can follow it up. Well, here's a little spot I'm going to try. I've got some exposed bedrock up behind me. Got some moss on it. I'll scrape that moss and wash that moss, see if I can find any. But here I want to show you that moss is 2 or 3 feet under the water, and moss doesn't grow underwater. So that just shows you how high the creek is right now. But I might take some of that moss as well. I really like using the moss because it acts like riffles or carpet in a sluice box. And so as the water flows over this, all the gold gets caught in that moss. So it's a great spot to look for gold if you can find it on exposed bedrock like this. So check this out. I was cleaning right here. There's a little dribble of water coming down. It's washing all the sand away, and see all the black sand that's leaving? So that moss was capturing all that black sand, all those heavies, and that's where the gold's going to be. Get down in these bedrock cracks, little hollows. That's the good stuff right there. lots of black sand. Oh man, I had to get back in the truck. The mosquitoes were so bad. But I did 2 pans, and I found 3 pieces of gold. Let me get my, there, now you can see them better. Let me get my up close camera there so we can see them a little bit better. There we go, there's 2 of them. And the third one's right up there in those rocks. So 3 nice little pieces right out of the moss. So now what I want to do is get a really up close look at those. I've got this little microscope, it clips right on my phone. I got a link in the description below if you're interested. But what I really want to show you is I'm hoping this is really coarse, like it's really angular. It's not flat and flaky. There's one of them. And see how it looks like a little nugget? It's not just a super flat little flake. That one's a little more flaky, but it's still got some angular edges on it. And then the third one over here, yeah, see, that one's like a little nugget. And so that tells me they haven't traveled very far. They're not super flat, pounded like Dan and I have found in the Fraser. These are little tiny nuggets, so they just broke free from their host rock, and they haven't traveled very far down the creek, which tells me that we're pretty close to the source. Well, I'm going to try and prove my case here, and I'm going to tell you a little story to do it. So in the 1970s, right along this road cut I'm walking down, the Forest Service expanded the road, and they did some blasting here in this little rock face behind me. And one of my past viewers came along here in the 70s, said, hey, that looks like an interesting little quartz vein that they exposed on the road. And so he started picking at it and taking some samples. There's an outcrop here somewhere along this road, and I found it at one time. I can't find it right now, but it assays over 1 ounce a ton. It's about 12 inches wide, little quartz vein right here in this Darrington filite. And there are no mines, there's no prospects, there's no recorded claims in this area. This is on the way up to the gold fields. There were thousands of people that walked along this old road, this trail, and they walked right over this gold vein. Because if you look up behind me in the forest, it's covered in 2, 3, 5 feet of overburdened duff, logs, trees, that kind of thing. And you just can't find anything. Here's a little closer look at this outcrop. It's metasedimentary rock. It's not quite filite. It's got a little bit more calcite in it, I believe, a little more marbly in composition, but it does have some calcite and quartz veins through it. There's another look at it up there. And I was actually up here 3 or 4 years ago, and it has overgrown so much just in the last couple of years. It just completely gets covered up with growth. Now, what this guy did tell me, and I found on a previous trip, is the outcrop doesn't quite parallel the road, but it goes back about 30 degrees off the road, back up on the hill. And I'm gonna follow that back up. I know a spot I wanna show you where there's a little outcrop, and I can show you what the vein looks like. But see, this is the stuff I'm talking about. I'm thick in it now, but it's just moss, logs. There's not a rock in sight around this stuff. So I don't know how you prospect this. The only thing I know to do is go to the creeks, because the creek bottoms, even these little tiny little dribbles off the side of the hill, they will sometimes expose bedrock, and that's really the only place that you can find exposed rock around here. Look at the stumps. Man, the trees used to be big here, huh? Big cedar tree. Cut them all down, probably to build a cedar fence or shingles for somebody. Well, there goes Border Patrol flying over. Probably wondering what I'm doing. I'm sure they've got heat sensing cameras and motion detectors and heartbeat monitors, and they probably know my blood type. So they know I'm here, but I'm just a prospector. One of my favorite forest flowers, Trillium, just about at the peak. 3 petals, 3 little leaves underneath the petals, and 3 leaves. One of my favorites. So when I say the creeks can expose bedrock, it doesn't necessarily mean they do. I'm standing in this little trickle. You can see there's some rock exposed down there. It's not bedrock, it's pieces. There's some rock down there. That's all called float. And for us, float is going to be very, very important in the next segment of this video. It's pieces of rock that have come off way up the hill, broke off the outcrop, and have rolled down, in this case this creek, washed down the creek. But it gives me a really, really excellent cross section of the rocks that are up there. So if there's a gold vein up there and a piece of it fell off and rolled down this creek, and I'm walking up the creek and I spot it, that's a great way for me to know, hey, up this creek farther, there's an exposed gold vein. Now the trick is, the percentage of this drainage that is actually that exposed gold vein is super, super tiny. So I have to do a lot of prospecting up and down this creek to determine if 1 or 2 gold veins are up there and they dropped 1 or 2 rocks. But it's the only way I can see the outcrops or what's up above, because there's nothing else exposed. So I'm gonna walk up this creek a little bit, look for some float, and that way we can get some kind of idea of what's upstream from us. Well, if I can brave the mosquitoes for a minute and talk over this creek, this is what I'm talking about. Now, I found this 4 or 5 years ago, so I didn't just discover it on this trip, but I want to use it as a prime example of what I'm talking about. This is a huge piece of quartz vein. It broke off the outcrop. I'm on strike more or less from that vein that was exposed in the road. So I believe the vein outcrop is right in here, maybe within 20 or 30 feet. I have not been able to find the outcrop yet, just this 1 or 2 pieces of really, really nice looking float. But this is a perfect example of a gold-bearing quartz vein that has been walked over for 120 years that is undiscovered still. It's right here somewhere, but I don't know where it is. So we'll take a kind of an up-close look here. You can see the quartz, but look right here. Very, very nice sulfides. Loaded with sulfides. Copper staining a little bit. Down this side as well. Lots and lots of sulfides. This is a beautiful, beautiful piece of rock. The old prospectors would get so excited by this. And you might be able to tell in my voice just sitting here, it's really, really interesting. I wish I could find where the outcrop was, but the one thing I can tell you is it's probably not below us, because rocks don't roll uphill. So it's either right here, we're right on it, mosquitoes, we're right on it, or it's up a little bit. It came from up the hill a little ways, but it's right here somewhere. I just wish I could find out where it was. Let me do a little poking around here some more and see if I can find anything else. This is my exhibit A of, I still think there's lots of good gold veins out here to be discovered. And hopefully using some of our improved geologic knowledge, improved tools, LiDAR, mapping, all this extra stuff, we can start finding the locations where we want to look for these things. These old guys, they were just walking around the hills. They didn't know what rock type it was. They didn't know how the veins were in place. They didn't know the geology. But we have all these new tools now, so we can really narrow down where we want to look for this stuff. And for reference, you know, the rock's right down there in the creek. And then if I pan around, there's the road. We're within 150 feet of the road. We're very, very close. It's not like I'm way up on the top of a mountain. It's right next to the road, and the road was built on the old trail that the old miners walked up 125 years ago. So we're right in it. If you were prospecting, you walked right over this one. Well, this thought just popped into my head. Gold is essentially float, right? We go down to the streams, we pan out the gold, and we find little pieces that broke out of the outcrop. The advantage we have with gold is that the physics of the stream concentrate it, so it's easier for us to find. So even though there's such a small percentage of the creek bed that's gold, we can use our knowledge that gold is super dense and find where it would concentrate, so then we can find out if there's any gold in the system upstream. So anyway, I just had that revelation, thought I'd share it with you. I just am out here babbling to myself in the woods. So if I'm giving you too much information, leave me a comment below. But if you like all my babbling, and I should leave it in on future videos, let me know as well. Here's one of these massive cedar trees that didn't get cut. You can look up there, beautiful tree. I showed one of these on a previous video and everybody jumped all over me because I calculated the value, the board footage in the tree and how much it was worth. This tree, 6 or 8 foot through in the bottom, it's probably a $50,000 tree for board footage. I'm not advocating you cut it down. I'm just putting it in perspective on how big and how valuable these trees are, just from an economic sense. But we still have some around the Pacific Northwest. Not many, but if you look in the right spots, you can still find them. Well, I'm a couple hundred feet to the west of where I saw that outcrop in that little creek. Here's another little creek exposed. There's a lot of float in it. And I'm gonna be looking for quartz. I'm gonna walk downstream because if I'm above it, there won't be any float above me. But if I'm below it, there will be either float here or all the way down the creek, if that makes sense. So I'm gonna work my way down the creek to the road and cross your fingers, see if I can find some more float or a vein outcrop in the creek. But I have not prospected this creek yet, so anything I find here is gonna be a new discovery. Well, I didn't talk about it earlier, but I'm noticing something here I wanna point out. In that other creek with that big boulder of quartz in it that I showed you earlier, the rock right around it was this kind of red, purple looking rock. And I'm seeing a whole bunch of it right here. And I haven't seen any of it coming down the creek. And so what that could mean is the vein is hosted in this purple red rock. And because I just stumbled across some of it, we might be very close to the outcrop. Now the purple rock, the purple colored rock could mean a couple different things. It could mean that it's a different rock type than the surrounding country rock that hosts the vein. Maybe, kind of unlikely though. What I'm thinking it means, and this is kind of typical for some of these quartz veins that get intruded into their host rock, is they have a baking zone. And so when these quartz veins got intruded, we'll talk a little bit more about that later in the video, but as they got intruded, they came into relatively cold rock and the fluids were very, very hot. And so you have this baking zone that can go out from, you know, a half an inch up to feet. And this purple rock may be the baked zone of the vein emplacement. So I'm pretty excited that I found this purple rock, and if it is the baking zone of this vein emplacement, I'm really, really close. I don't see anything real obvious right this second, but it's just something I wanted to point out to you. So if you're prospecting, mosquitoes. So if you're prospecting for quartz veins, it's one little trick you can use. Look at the size of these mosquitoes. Man, they're everywhere, and they're big. But look at what I just found here. It's not a very big piece, but it sure looks very similar to that other quartz we were looking at over in the other drainage. I can't sit still too long, the mosquitoes get after me. But an example, purple rock, quartz vein. I'll look down here a little bit more, but wherever I find that purple rock in the last 2 drainages, I found pieces of quartz vein. Hey, look at this. Here's a piece I found laying out in the forest floor. The creek's right over there, but I mean, it might be right here. It could be right here. It's so hard to prospect in this. Now here's a section of bedrock that's exposed. It's not purple, it's back to that kind of blue color. So we're out of the baking zone, if that's what that was. But there's still a possibility for float down below because the quartz vein may come across right up here somewhere. but that's a nice exposure of bedrock showing us what's kind of under our feet. Well, you guys said in my last video you want me to just talk about everything I see, you enjoy it. So here we go. I'm just gonna blabber on about this stump here behind me. This is a big old cedar stump. They came through probably in the 20s or 30s or 40s and clear cut all these trees down. But I wanted to talk about this notch right here in the stump. That's for a springboard. And what the old loggers would do, especially on these big, huge cedars, is the cedars would have butt swell. So right where the tree comes down to the ground, the first 5, 6, 10 feet, flare way out. And it's way, way thicker to cut through the butt swell than just 10 feet up. And so the loggers would cut these notches, they'd shove their springboards in there, they'd climb up on their springboards, and then they could cut the tree from the springboards above the butt swell. So on a lot of these stumps, you'll see these springboard notches, many times 2 or 3. Here's another one over here. They would make the face cut, they'd go around to the back side, make the back cut, and drop the tree. So just a little bit of history on why there's some notches cut out of some of these old stumps around for the logger springboards. And if you guys are interested in any more logging stuff, I've got another YouTube channel called S&J Forest Products. I'll leave a link in the description below. You can check that out. I got a lot of logging stuff going on over there. The other thought I've had about all these prospectors that came up into the hills, you know, looking to make their riches and get rich on gold, is a lot of them weren't trained prospectors or geologists at all. They were, you know, the kid working at the local market, and the guy at the sawmill, and the guy fishing, and the guy that worked on the docks. They had no idea what they were looking for. So even though you had literally thousands and thousands of people wandering these hills for a couple years, they wouldn't know a gold vein probably if they stumbled upon it, or much less how to prospect for them. And so that's one of the other things why I think a lot of the area around here that may have been walked over and looked at maybe isn't necessarily completely discovered, because the people that were doing it didn't know what they were looking for. But now I want to drive up the valley more and go to a spot I've been looking at on the geologic maps that is very, very similar to where a lot of the rich gold deposits in this district have been found. And I want to do a little prospecting up there. I was just driving up the road and I saw something here I want to show you. It's a pretty cool little historical thing. I don't know if you can see behind me, but there's some cedar trees back here, but the bark has been stripped way up the tree. Now, a little bit of history about the cedar trees around here. They were really, really, really super important to the Native Americans, the native population that lived around here. The Salish Sea is what the Puget Sound used to be called, the Salish people. They were very, very reliant on the cedar. They made their dugout canoes out of it. They used the bark for all kinds of stuff. And they would come along and they would take a sharp rock or an axe or something, and they'd cut along the bottom, and then they would pull the cedar bark whoosh, and it'd strip right off the tree way up. And they would do this just around a portion of the tree so it doesn't kill the tree, and then they could harvest the cedar bark and they'd make baskets out of it, hats out of it, they'd make clothes, blankets, all sorts of stuff. So since then, the federal and state governments have allowed the local tribes to come and strip some of these cedar trees, and it only happens in real special locations. It's pretty cool. It's kind of a nod to the local history and the native people and what they did and how important the cedar tree was to them. And then you look around like I showed you earlier, and when it was settled by Europeans, all we left was stumps. There's just cedar stumps everywhere. So a little bit of a different strategy on how to deal with the trees and what you need from the trees. And here's an example of an older one where they cut the bark down here, and the tree has grown, I don't know, 2, 3, 4 inches on each side. So it'll grow around and it'll heal up this scar from the cedar bark. But this is a pretty cool site because I'm looking around and there's lots of trees that have been stripped just around, you know, a third or half of the tree. So it's the local people still doing what they do and come up and harvest the cedar bark. Well, I think this is about the best place I can get to give you kind of a regional view of what we're talking about. So the road follows the creek up the valley. This valley was glaciated back in the last ice age and probably had alpine glaciers that ran all the way down it. It's flat-ish on the bottom, and then these super, super steep sides up both sides. You can see maybe if I pan across here, it just goes, you know, kind of straight up on that side, and then over on this side, same thing. It just goes straight up the valley sides. It's very indicative. You have these perched waterfalls. So there's a cirque up there, a basin, kind of a flat spot, and it drains out, and then it just falls right down into the forest floor. That's that U-shaped valley. The glaciers came by, scraped it, super steep, flat in the bottom, and you have these perched cirques that drop out all this water down, make these amazing waterfalls, hence why it's called the Cascades. Way back in the distance, you can see a mountain that's kind of rounded. It's gray in color. That's the Granite. So we saw that down in the creek. That's Granite. It weathers different, and it's real, real obvious if you know what you're looking for. Like Yosemite is all granite. Sorry, my petrology teacher's rolling over right now, but we're gonna call it Granite. It's intrusive, quartz-rich rock. We're gonna call it Granite. So Yosemite is just covered in granite. It makes those big, huge dome mountains. Same back there, you got a dome mountain. Now, where I'm standing and down valley from that granite, you have this different rock type. It's gray, it's a little bit more of a slope former. The trees grow on it a lot better. You can see this is all treed, whereas that granite peak is not. Down both sides, this is the filite. This is that metamorphosed sedimentary rock I was talking about earlier. We saw some of it in the creek. Why this is important is because the two other very large mines in the district that produce a lot of gold are found right at the contacts between the granite and the filite, within 500 feet on either side. And the gold veins run across that contact. So we're gonna go up the valley, we're gonna try and find the contact between the filite and the granite, and we're gonna prospect all along that area and see if we can find any quartz float, quartz boulders that have knocked off the vein, fallen off the vein, and fallen down the hill. And we're gonna scour all over the talus underneath these cliff faces and see if we can find any gold-bearing quartz. Well, we sure do have some amazing views here. I'll get my face out of it so you can enjoy them. But here again is a perfect example of a cirque basin up there. The glacier came by, wiped out the drainage, and so now the cirque basin just comes out and drops down into a waterfall right down into the creek bottom here. Big, huge talus slope. All that rock that comes off that hill flows down, makes this big talus, and then down into the creek that washes it down to the ocean. But what I really wanted to show you was over here on this side, a little bit different view. This is a little drainage coming off the north slope of the mountain. Every single rock I see in here is filite. Darrington filite, Darrington filite. So this tells me that this whole basin, everything up all the way to the top, is pretty much all filite. I don't see any other rock types in here. And so that tells me that we haven't gone even close to the granite contact yet. The granite contact may not be a line that I can put my finger on. It may grade, it may sweep in and out of each other, but what this tells me is I need to go farther up the valley because this is all still filite. We're getting closer. There's the granite knob I showed you earlier. And all this over here with the trees is still filite. Prospecting from the car. It's my favorite kind. So all these alluvial fans coming out of these drainages, that talus stuff I mentioned earlier. I won't see any exposed bedrock until I get up to the cliff face. All that talus, all that alluvial fan is float that's dropped off these faces. All right, I got it on super duper wide mode, so hopefully you guys can see everything I'm going to talk about. On my left is the granite intrusive batholith. On my right is the filite metamorphosed sedimentary rock, and somewhere in between those is the contact. Now let's talk a little bit about how these rocks got here. Regional, huge picture stuff. Off the coast of Washington, we have the subduction zone. The Pacific Ocean plate is subducting under the North American plate like this. The thing that was drilled into my head in geology is as that thing subducts, the plate does not melt. but releases a ton of water. That plate is waterlogged. As it goes down, it warms up and the water comes up into the North American plate. Once that water intercepts these felsic, silica-rich rocks, it melts them, causing volcanism. That's why we have Mount Baker, Mount Rainier, Mount Adams, Mount Hood, Mount St. Helens, all the way down the Pacific coast. What happens is all that water circulating in that hot environment around all these rocks is getting in there and dissolving all these metals: iron, copper, nickel, lead, zinc. It's dissolved, and we're talking hot water. The environment this is in is hundreds and hundreds of degrees Fahrenheit, maybe thousands of degrees. The pressure can keep that water super hot, super acidic. So as that water filters around through all these rocks, it's dissolving all these metals and concentrating them in this fluid. Now, as this huge plumes of magma come up into the crust, they start to cool. The stuff that doesn't make it all the way out to the volcanoes starts to cool off. And as it cools, it puts a huge amount of pressure on that liquid brine that's in this magma chamber. And eventually it gets such high pressure that it breaks or shatters or fractures, and it shoots that mineral-rich brine out into the surrounding rocks, sometimes out into other batholiths, other host rocks. But you've concentrated all these metals down to this super hot, rich fluid, and then you inject them into these other rocks. So that's how the batholith got here. That's how that granite got here. The filite is a sedimentary rock. It's old seafloor sediment, so stuff that was deposited way out in the ocean over millions and millions of years. It's essentially mud, right? Everything that's shedding off the continents into the ocean gets deposited as mud, and layers and layers and layers and layers up over the millions of years. As this subduction is occurring, it's scraping off a lot of that seafloor sediment as it goes down. And so the Olympic Mountains, which are out on the very coast of Washington, are made up of pretty much exclusively scraped off sediment floor. It's called an accretionary wedge. So it's just built up over and over and over of all these seafloor sediments that got scraped off this subducting plate. Well, some of that stuff made it as far east as the Cascades, and you have the Darrington filite. Now what happened is, as that stuff got scraped off, some of it went down further and got kind of worked up into the subduction and the volcanism, and it got metamorphosed into filite. So you took mud that probably went into slate, and then it got hot and got squeezed and pushed and squirmed around, and it turned into this filite, right? And then it accreted into the Cascades, and this volcanism has come up through. The important part of this is the filite may be the source of some of the metals. Those seafloor sediments have very disseminated amounts of copper, gold, silver, all that kind of stuff. And when you get this volcanism coming up and all this hot water circulating around, it could have gone through that filite over millions of years, filtered through that filite, dissolved all these goodies, and then concentrated in that magma chamber and broke into the filite. One of the reasons why you have such rich gold veins right at this intersection, just to the north of me, is you have this magma chamber, you have the filite as the host rock, and that's where it went. The mineral water fluid came from the batholith, shot into the filite, and it's not like it's shooting miles and miles and miles away. It's shooting a couple 100 feet in this case. And so that's why I'm not looking 2 miles down river for these deposits. I'm looking right at the contact because it came from that mountain and it shot into that mountain. So I'm gonna work up here behind me. We're gonna figure out where the contact is, hopefully, look for some float and try and find some gold veins. Now I can tell you right now, I do not wanna walk up through that. That is a hiker's nightmare. So I'm gonna try and come over here and run up this little stringer of timber here. Hopefully the brush won't be too bad, and then I can get up there along the face, and we can come across the face and see what we can see as far as the rocks are concerned. Wow, here's some geology in action for you. So the road got completely washed out by the creek, but it looks like a fresh rock fall came off of this hillside right here behind me, dropped all this debris down into the valley bottom, pushed the creek over against the road, and then washed it out. So there you go, geology in action. One thing I forgot to mention on my little subduction zone geology rant back there is all that happened miles under the surface. So this felsic magma, the cooling, the vein injections, that all happened miles deep. And then as mountain building has occurred, it's all been brought up from deep underground as the Cascades have come up, and all the stuff on top is eroded away, and now you have these big granite batholiths exposed at the surface. So I wanted to get that little tidbit in there for you as well, just to show you, and it kind of goes to show you with that rock fall earlier, the mountains are still building and they're still eroding. And so what's a mile under our feet now, which may have super rich gold veins in it, in the next 20 million years will be brought up to the surface. I'm a couple hundred vertical feet above the valley floor. I haven't made it up to the outcrop yet, but I'm starting to see a bunch of this big float that's come down the hill. So I want to knock it off and see what rock type we're dealing with. I can tell you it's probably granite by the looks of it, but we'll see here in a minute. Well, color me surprised here. When I broke this open, it's quite a bit darker in composition than the granite. This is probably closer to a gabbro, which means it has less quartz. It's more mafic. The crystals are still quite large, so it cooled slowly underground. But it's not the super felsic, intrusive stuff I thought it would be. That doesn't deter me at all. It's just interesting that it's not just this big granitic intrusion. There's actually some more mafic stuff involved as well. But while I was whacking on this, there's a real rusty rock down there I want to go look at. Also that gabbro looking stuff, but it's highly oxidized on the surface, which means it has either been weathering a lot longer or it has a higher iron component. I have to cross this little chute over that next stringer of timber, and I learned something in the last video. On the West Coast, we call this Devil's Club. It's like the cactus of the Pacific Northwest. But a lot of people on the East Coast commented and said, hey, that's not Devil's Club, that's Devil's Walking Stick. So for all you East Coasters out there, found some Devil's Walking Stick. Typically grows in these avalanche chutes. It's real nasty, but something you just got to contend with. Well, it's time. I've gone through the timber as far as I can. Now I got to get out into that. I'm right up kind of under these cliffs. I'm just going to traverse along under the cliff face until I can find that filite contact. I'm real confident I'm in the granite right now. All this talus, all this float is intrusive volcanic. So the filite is over that way somewhere. I just got to go find it. Oh, I have something I'd like to say. A little PSA, if you will. If you or someone you know thinks it's a good idea to hike through Tag Alder and Devil's Club to go and look at some rocks, don't do it. I'm in pretty good shape. I just turned 40, logging, mining, I stay real active. I don't want to do this anymore. I don't know how those guys did this. They had to walk 60 miles from Bellingham through mud and rain and crap and brush. And if they made it up here, then they had to walk through this stuff to go prospecting. And I will tell you this, I've been doing this about an hour and I want to go home and go to bed. I want to go home and just not do this anymore. And it would have taken them 5 days to get to where I'm at. I drove up here and I've been doing an hour and I want to quit. So I'm a wuss, or they were really tough. The only consolation prize so far is the views aren't too bad. There's down valley, there's across the valley. I think that's Ruth Mountain. And then looking across and up, there's a great example of a glacier carved valley up towards Hannigan Pass. Now another thing that's got me a little bit excited is I'm sitting in this big rock scree, but I see quartz boulders around. So let me calm down a little bit, catch my breath. But I want to go, I think that's a big boulder of vein quartz right there. Pretty excited about it. We'll go take a look in a minute. So here's what I'm looking at. This sure looks like a big boulder of quartz to me. There's another little piece there. There's a piece there. There's some up there. There's a bunch of quartz there. The question is, does it have any metal in it? Well, it's vein quartz, all right. Nice, pure, homogeneous quartz. Doesn't look like there's any metal in it. But what this tells me is the geologic processes that we're looking for are going on in this area. And I'm kind of curious now to crawl up under this cliff face and see if I can find a vein outcrop somewhere along in here, because this is just a big pile of float that came down the hill, and so the vein is up there somewhere. I'm walking up, there's just quartz littered everywhere now. I'm getting real close to something. I'm also running out of room here. I think I found it. I think this is it. Quartz through here, quartz up there. I'm also seeing, I think what's a quartz stringer right there, comes down through here. Oh yeah, right under that cedar tree there. What do we got over here? I'm gonna do this without killing myself, because it's kind of steep down there. Yeah, look at that. There's a quartz vein right there. Right there. Look at that. See? Footwall, hanging wall. I don't think this is quartz, but there's a vein right there. Goes right up the hill. Right there. Huh. I found one. I didn't actually think I was going to find one. Huh. Well, that's cool. Wow. Well, we proved that up pretty nicely, actually. There's a quartz vein that runs right up into the brush there. That's away from the filite contact. I really want to get over to the filite contact, so I'm going to work my way to the west. But I think we've proved the concept pretty well that we're in the right geologic environment. I mean, we've got quartz veins, we've got intrusive rocks. I can't say there's a lot of metal in there. There wasn't a lot of mineralization. But like I said earlier, the geologic activity that forms these veins is going on right here. So we're in the right spot. And most of the profitable mines in the district are in the filite. And so what might happen is, as the fluids inject into the filite, the chemistry changes. There maybe is something that causes the metals to drop out in the filite. And so even though we don't have really high mineralization in this vein, we're still in the granite. So I want to work our way over to the filite and see if we can find some quartz veins over there and see if they're mineralized. Well, here's some pretty flowers. It's like a nice little spot to sit and take a rest. But I want to look at these rocks. I've come across that little waterfall. We are in the granite now, that more felsic stuff. The trace of that vein comes down right through here and across the creek, but I don't see it up on this face here. But I will pan over. Oh yeah, that's not a good way to go. I might have to go down into that brush. But I'll pan over. You guys can take it in here. Looking up towards Hannigan Pass. And not too long ago, that whole valley was filled with ice. I just came across this little mountain stream here, so I'm working my way around. I don't see any filite in it. It's all granite or intrusive rock. But I'm going to walk up and down about 50 feet or as much as I can stand and see if I can find any quartz in it. I found a few pieces I like. What do they look like? Well, there might be some sulfides in there. Let me get my close-up camera here. I'm interested in that red stuff. It looks like garnet. Might be garnet in there. Here's the other half. Yeah, those look like garnets. So I don't know, can you have garnet in vein quartz? I don't think that's really typical. What do you think about this rock? Let me know. Leave me a comment in the description below. I just stepped out of that stream and I want to show you, I came across this little outcrop. That's not granite. That's filite. And on the other side of that stream is granite. So we might be standing kind of right on the contact here. That stream actually may be it. Running down, eroding out of that kind of weak point between the two rock types. And I want to show you, I came across this little outcrop. That's not granite. That's filite. And on the other side of that stream is granite. So we might be standing kind of right on the contact here. That stream actually may be it. Running down, eroding out of that kind of weak point between the two rock types. Here's our two rock types. This is east of the creek towards Hannigan Pass. I thought getting it wet would help, but maybe it doesn't. This is clearly intrusive, a little more mafic than we've seen maybe on some of the lighter colored stuff, but very much intrusive igneous rock. And that's right out of the creek. I'm sitting 20 feet from the creek and I just broke this piece off. Again, I think the water is hurting us because it's shining on it, but this is filite. Old beds, foliation, very fine grained, kind of uniform, dark gray in color. And so we're sitting on the contact right now. So one of the interesting things to me is we're right on the contact. That quartz vein I found earlier is about 300 linear feet to the east. So it's very close to the contact. But I think it's super exciting that we're on the contact. We found the point where those two rock types meet. The granite intruded right to the filite, and then the filite is the rock type to the west. So very, very cool stuff. Well, this is an interesting spot. I've continued west from the contact. Up behind me, I'm in this kind of scoured gully. All that bedrock is filite. We'll go take a look. It's all super, super obvious Darrington filite. All of the float is all granite, all intrusive igneous. So what that tells me is up here not too far, the granite must outcrop and make the rest of the mountain. And so you have a situation where the contact may come up and wrap around and the filite is down low and the granite has intruded up and over the top. I'm not sure, but you know, there's a lot of granite up there and there's filite right here. So that's kind of my working theory right now. Here's a few goodies. Let's see what we got. Nothing terribly exciting in that one. What do we got here? That looks like the same stuff we saw in the creek that had garnet in it. I don't see any garnet in it now, but it looks very similar with that little green, those little green flecks in it. Maybe chlorite or epidote. And then I found this guy, super oxidized. Let's see if we can get a fresh face on him. Yeah, that's pretty mafic in composition. A little finer grained. Probably a dike. Intruded, a mafic dike. There's some of those around I've seen. They intrude into the filite and into the granite, and they're super dark. They look kind of like basalt, and they cool quickly, so they're fine grained, and they typically weather all rusty like that because they're full iron. Here's a quick look at two different compositions of magma. Felsic, white, more silica, more mafic, darker, less silica. And so as you look up and down this wash, you'll see all sorts of different compositions of magma. So there's probably several different pulses that came up through, combined as they cool. Sometimes the mafic stuff kind of concentrates into the magma chamber and cools last and gets a little darker, a little bigger crystals like that. So the intrusive stuff we're calling granite is a whole suite of different rock types, but we're just calling it granite. I'm walking up this filite drainage here. It goes up a long way in filite, but still almost everything down in here is granite boulders. But it's so much easier walking up this drainage. There's no brush. It's all swept clean. I think I'm gonna get cliffed out here in just a minute. But I think there's another drainage right over to the west here, left-hand side of the screen. I really was hoping to find the granite contact. Well, I took 3 steps and I found some granite outcrop. It might be a dike, but right there is granite. In situ, meaning in place, bedrock. It looks like it's maybe a dike because all that up there is filite still. There's a little bit more granite. Here's a good look at it in the stream bed. Granite and filite. And like I mentioned earlier, we might have a lot of fingering going on here where they finger and interlace each other as the granite intruded. It didn't just come in as a big blob, you know, it's not like a balloon sitting next to the filite. Like I say, it may kind of be interlaced. And I don't want to hear any fingering jokes in the comments. Well, I've made it high enough. I think I'm in the granite. There's a granite knob, that's granite. There's a little dike running through there. That's all granite. There's some filite over there on the west with a nice dike running through it. So we're kind of right on another contact here. I haven't seen any quartz in the creek though, so we're not seeing a lot of float of anything that looks real promising. I'm going across to the other drainage to the west, but you want to talk about some dug firs that have had a piss poor life. Look at this guy. There's a couple more behind me here. Look at those nasty things. They got germinated here right under this rock face, and they grew their tops up above that rock face, and snow keeps coming and sliding and taking out their tops over and over and over again. Holy cow, I've never seen trees like that. Look at that gnarly goblet top looking thing. The tree's probably 300 years old. Well, I'm trying to get into the second creek, but there's really no good way to do that. It's just a cliff all the way up and all the way down. So I'm gonna have to go way back down that drainage I came up and come across and get it from the bottom, I guess. But while we're here, we'll look at some views. Well, I'm in this other canyon. You can see up behind me, it's real steep. I got down below it. I'm gonna try and walk down this creek a little ways, maybe just all the way out to the road, we'll see. Here's an interesting rock I just plucked from the creek. I'm not sure what's going on there, but it's really screwed up. Greens, it almost looks like maybe it's some of that lanite stuff I've seen in the past up and around here. Let me break it open. Yeah, that looks kind of like that lanite stuff. Right through there, right through there. I might have to take him home. I found another piece of that lanite stuff. I don't think that's what it is actually. It's definitely some quartz vein type of material. I don't know what the green is, maybe chlorite. But that's the best looking stuff I've seen all day. I've got the one rock in my pack. I think I'll take this one home. I want to slab it and get the microscope on it and see if we can see any minerals in there. But this isn't bad looking stuff. There's bears around. Hopefully not between me and the truck. I'm almost done. I really don't want to see a bear. Let me just get to the truck so I can sit down. Well, I'm walking back to the truck now. It was a great day. I am really tired. My knees are pretty sore. But let's get these rocks back to the rock shop. We'll slab them up and see what we can find. All right, let's see if I can do this and makes any sense. There's our big granite intrusion, right? That's all of our big intrusive volcanics. I walked up this little string of timber right here, up under that big first face you can see right at the tops of those cedar trees. And that's where I found that first little quartz vein, actually pretty good sized quartz vein, running right across there. Then I came across the face under this one, and right there's that little creek running right up and down. That's where we first saw the contact between the granite and the filite. Then I came across over here, got into this drainage, walked way up there, tried to come across into that canyon where that waterfall is. Couldn't cross there, so I had to come all the way back down underneath, and then I walked that drainage all the way down and out. So that was a long day. I think a drone would really help. What do you guys think about that? I think I need a drone. We're back in the rock shop. Let's get a few of these chunks slabbed up and see what we can see in them. Well, for all of you that made it this far in the video, I got a surprise for you. I've got one last box of gold ore from my gold mine from last season. So if you're super excited to get your hands on some ore from my gold mine, now's your chance. You don't have to wait 3, 4, 5 months for more stuff to get mined on season 2. So check it out on eBay, link in the description below. Here's our first piece. That green in there looks a lot like that lanite stuff. This is clearly from a fault zone. It's all brecciated, broken up, many different generations of stuff getting in there and cementing all these little brecciated pieces together. But let's get our microscope out and we'll take a look, see if we can see anything. Here's those green pieces in that really nice quartz matrix. Then as we move down over here, you get this brown stuff with some quartz around it. And this could have been laying on the surface for thousands of years. So if there were any sulfides, they may have all been weathered out or weathered to oxides. Like that right there looks like it might be some sulfides kind of right in the middle there. Some of those gray, steely gray pieces. And here's the second piece. A little bit more interesting. Still have those clasts, those green clasts in there. Some re-cementation by quartz. Looks like this is from a fault zone. I'm quite sure both of the pieces of float I found were from the same source. What's that right in the middle there? Is that a little piece of yellow gold in that little pocket? There's another little piece of something right there. Right in that little band. What it looks like is that was the last little gasp of stuff to cement out in this vein system. Yeah, I like these little black bands of stuff that have this little black mineral in them. All right, everybody. Well, thanks for watching. Hope you enjoyed it. We'll see you on the next video.